We use cryptography in many aspects of our lives, and in this video, we'll go through a number of these important cryptography use cases. We rely on our mobile phones, our tablets, and other devices to be able to provide us with information throughout the day. But these mobile devices have limited storage, limited CPU, there's a certain battery life associated with these devices, and we still want to be sure that all of the data on these devices is secure. So of course, encryption is a great way to protect the data that's on these devices. But because there is a limited amount of power in CPU, we need specialized encryption for these devices. So it's very common to use a smaller symmetric key, especially in conjunction with elliptic curve cryptography, or ECC, which is specifically designed for environments like this, where we need very powerful encryption on a device with a limited number of resources. If we need encryption that works very fast and very efficiently, we can use the low latencies associated with symmetric encryption. Symmetric encryption also has smaller key sizes, so it might be a better fit for a number of different encryption projects. And it's also important that we're able to ensure the data remain valid. We want to be sure that there's no opportunity for data to change or be modified without us knowing about it. So using some type of hashing provides that data integrity. We could also use larger key sizes and increase the quality of the type of encryption that we're doing to be sure that we have the most powerful encryption available. If you want to keep information secure, then you'll want to use some type of encryption. This cryptography allows us to keep things secret and private, and we can encrypt information that's either part of a file, we can encrypt information on an entire drive, or perhaps even on an entire device. By using hashing, we can also maintain the integrity of data. We could use a hash as we're downloading files to make sure that the file download has occurred properly, or we may want to store information like passwords, and hashing allows us to store the password without revealing that password to others. Cryptography also allows us to hide information through the use of obfuscation. For example, malware very commonly encrypts the malware itself within the software that it's transferring in order to get around the signature-based detection that we have in most antivirus and anti-malware products. When the application is executed, the malware is decrypted and it becomes executing on the local machine. If you've ever logged into a device or authenticated onto a network, then you've taken advantage of the authentication capabilities of cryptography. We often use hashing to be able to protect those passwords, and we're usually doing this so that no one can see the password that we happen to be using. We might also add salt or some other type of randomization to the password so that everyone's hashed password is very different than everyone else's. We can combine this hashing with asymmetric encryption to create non-repudiation. This allows us to confirm that the information that we're receiving from someone really did come from that person. This is usually implemented as a digital signature so that you can be assured that not only did that data come from that person, but none of the data that you're looking at as part of that digital signature was altered from the time that it was originally sent.